In a chilled water plant, pumps don't run at a fixed speed. They need to ramp up and down based on system demand. In this video, I'll explain how a pump's VFD communicates with the BMS, or a third-party plant controller, and how VFD drive is controlled. Let's start with the key components in the system. The pump, which circulates chilled water through the system. The VFD drive, in this case an ABB ACH580, which adjusts the motor speed. The pump VFD driver could be from different manufacturer in the HVAC field. I used example of ABB VFD driver for this video. The BMS or plant controller, which could be primary loop controller, secondary loop controller, or condenser water loop controller, which decides how fast the pump should run. This third-party controller can run alone or can communicate with BMS. And finally, safety devices like third-party control board and current switches that keep the system reliable. There are two main ways the BMS talks to the VFD. First, through hardwired signals. BMS sends a 0 to 10 volt signal to the VFD to control the speed of the pump, and VFD sends feedback a 0 to 10 volt signal to the BMS for speed or frequency return. BMS send a digital DI, start and stop signal for pump and safety interlocks, flow switches, wired to DI terminal at the VFD drive. The VFD in turn sends feedback to the BMS, such as a run status, speed feedback, or alarm condition by relay outputs. These relay outputs could be normally open or normally closed, NC contacts. Second, through network communication. The VFD drive usually communicate through BACnet MSTP protocol. They can also communicate by BACnet IP protocol. That means the BMS can directly read and write values inside the VFD. Things like motor speed, kilowatts, alarms, and even start or stop commands. This allows for richer data and easier integration. Here's how it all comes together. The BMS or plant controller monitors differential pressure, DP value, or flow in the chilled water loop. If the building load increases, it calculates a higher pump speed and sends that command to the VFD. The VFD ramps the pump to the new speed and then reports back to the BMS with actual operating data. Meanwhile, a current switch wired to the motor leg provides proof of operation, so the BMS always knows if the pump is physically running when commanded. Even though BACnet can handle most of the communication, we still use hardwired I/O. Hardwired signals are simple, reliable, and independent of the network. They ensure that critical commands like start, stop, and safety interlocks are always available. BACnet, on the other hand, gives us detailed monitoring and advanced control. Together, they provide both safety and flexibility. In a most chilled water plant, there's often a master plant controller that stages chillers and pumps. The pump VFDs are part of that loop. The master controller tells them when to start, stop, or ramp up, while the BMS supervises the entire system and provides alarms to operators. So that's how your pump VFD and BMS, or third-party controller, talk to each other, and pump VFD is commanded to operate. Understanding this setup is key to troubleshooting, commissioning, and operating any chilled water plant.